Today we'll be presenting to you about chemical safety in pharmaceutical laboratories. Chemicals are essential in pharmaceutical laboratories. They support drug development, healthcare, and medical advancements. Hazardous chemicals pose serious health and environmental risk. A proper chemical safety management is critical to prevent a long-term harm. Types of hazards in pharmaceutical laboratories include chemical hazards, biological hazards, fall hazards, environmental hazards, ergonomic hazards, last but not least, fire and explosion hazards. Chemical hazards involve toxic, corrosive, flammable, and carcinogenic substances. Improper handling can cause severe health effects. It is regulated under OSHA Hazard Communication Standards (HAZCOM). It requires chemical labeling, safety data sheets, PPE, and training. Spill response are governed by HAZWOPER regulations. Biological hazard exposure to microorganisms during drug research and testing. Risks depends on job role, ventilation, and exposure level. OSHA classifies exposure risks from very high to low. Control using PPE, ventilation systems, and hygienic practices. It is covered under bloodborne pathogens and respiratory protection standards. For fall and ergonomic hazards, wet floor and a poor housekeeping increases slip and fall risk. Fatigue and overcrowded workspaces worsen the accidents. OSHA requires proper housekeeping and ergonomic controls. It is also recommended a job rotation and mechanical liftings aids to reduce injuries.
So next we're going to talk about environmental hazard. Environmental hazard in pharmaceutical laboratory refers to the improper chemical management under the hazard communication standard, which is number 29 CFR 1910.1200. For example, the toxic chemicals released to the air, soil, sea, and drainage systems. This release of toxic chemicals will destroy the habitat in our environment. So how do we deal with this? First of all, the store used chemical, we put it away in a container, in a special container before we dispose it away from the public. The next one for the vapor, so we use fume chamber with neutralization, like for example the carbon filtration system before we release it back to the air. So we must integrate all the systems with proper safety data sheet SDS according to the Global Harmonized Systems of Classification and Labeling of Chemical, the GHS classification. We have fire and explosion hazard. So this type of hazard refers to any combustible chemicals that can burn rapidly. In pharmaceutical laboratory, chemicals that are volatile and fine drugs are flammable. If dust is suspended in the air, it can become explosive. So it's not just volatile chemicals, but the dust that is in the air can also become flammable. In the presence of oxygen, heat, and fuel, the dispersion can cause rapid combustion. So we all know that chemicals such as ethanol can burn, but what about the dust? So initially, the explosion in processing area where dust is accumulated may dislodge more accumulated dust into the air. So as a result, if ignited, the additional dust dispersed into the air may cause secondary explosion. So this secondary explosion can cause more destruction than primary explosion due to the increased quantity and concentration of dispersed combustible dust. So in accordance with OSHA hazardous location 29 CFR 1910.307, pharmaceutical laboratories utilizing hazardous chemicals must implement electrical management to mitigate the risk of fire and explosion. So basically, the first explosion comes from electrical explosion. But after the electrical explosion, the dust will fly everywhere, and then from that first explosion, it will cause the explosion of the dust, which ultimately will reach to all parts of the building. So the next one on the list is risk assessment. This is very important because we want to identify potential hazard before they occur. In Malaysia, we use HIRAC form, which stands for Hazard Identification, Risk Assessment, and Risk Control. Here are some of the examples of HIRAC form. Next, we're going to talk about Safety Improvement Plan. So Safety Improvement Plan consists of 4 stages, which is the first one, mitigation. Second one is preparedness. Third one is response. And the last one is recovery. So for mitigation, it's basically just prevention. So we want to stop the accidents from happening. So to stop accidents from happening, we should properly install electrical appliances, and we should follow the OSHA rule. For staff, they should wear the protective equipment such as gloves and goggles. Next one is preparedness. So preparedness is basically just planning. So examples would be like fire drill. So during fire drill, the staff and workers should know how and where they should meet during accidents. Other than that, for examples like firefighters should also know where is the nearest fire hydrant so that they can act during an emergency. So the next one is response. So response is basically just like planning, but in this case, the emergency actually happens. So when the emergency happens, the staff and the workers goes to the meeting place, and the firefighters goes to the fire hydrant to get the water to fight the fire, and the medics will help the injured. So recovery is basically fixing after the emergency. Such examples would be like giving medical care to the staff. We can also give emotional support, and we can also build back the new laboratory in case it is damaged, and also giving back the works to the staff with adequate training. Last but not least, we have ethical and societal impact. We can follow American Institute of Chemical Engineers Code of Ethics, and we can also follow National Society of Professional Engineers Code of Ethics. Inside this code of ethics, engineers must prioritize public safety and environmental protection because their decisions affect workers' health and the sustainability of the environment. In conclusion, pharmaceutical laboratories require strict regulation to prevent hazards from happening. We must follow OSHA standards and the four-phase safety improvement plans: the mitigation, preparedness, response, and recovery. Lastly, engineers have codes of ethics to prioritize public welfare and the environment. That's all from us. Thank you for listening.